Assalamu alaikum wa rahmatullah. Hi everyone. Let's continue working on question 4 from the cover of grade 12 elite. We are at question 9 of question 4-5. We have a region bounded by the vertical line x equals 1 and two other functions. We need to find what the volume of the solid with cross sections perpendicular to the x-axis, and those cross sections are rectangles with height 5 times the length of the base. So as long as the question says perpendicular to the x-axis and they are rectangles, we don't need to isolate. X, right? So, but to find the volume, okay, you will integrate from this x value up to 1. Okay, but we don't know what's the lower limit of this integral. To find the intersection points, you can use your graphing calculator, or you can set the two functions equal to each other and then solve for x. You will get x equals 23873. 23873. This is the number that goes here. 73. Okay. Now, the width or the length of the base should be the difference between the two functions. The upper one is root of x minus the lower one, which is e to the power of minus 3x, but we will multiply by what? 5 times the length times 5 times what we just got, root of x minus e to the power of minus 3x dx. Now use your calculator. You should get 1.554. So, moving on to the next question, which is question 10. It's a calculator active question. We have region R in the first quadrant bounded by the x-axis and two other functions. Find the area R. So to find the area R, this is question 10. We are going to, this is 1, this is 2, 3, 4, and this is 5. Now this intersection point is slightly smaller than 4. So how do we find this intersection point? You can set the two functions equal to each other. Ln of x equals 5 minus x, or using your graphing calculator, you can figure it out. So the intersection points here will be 3.69, 3.69344, comma 1.3656. Okay, so to find the area, instead of copying those numbers, let's name them A and B. Now to find the area for part A, you will go from 1 to A of what is the function? The function that we have is ln of x, okay, dx, minus, now we will go from A to 5 of the linear function 5 minus x dx, and this answer should be 2.986. This is part A. Okay, for part B, it says region R is the base of a solid the cross sections perpendicular to the x-axis are square, right, but do not evaluate an integral that gives the volume. So, the volume is given by the integral of, we can go from 1 to A, okay, 1 to A of the first function, which is ln of x squared, right, dx plus, now you go from a to 5 of 5 minus x squared dx. And we don't need to evaluate, we just need to set up what? The integral. Now there is also part C. It says the horizontal line y equals k. There is a horizontal line y equals k. Okay, that's somewhere here. Okay. Divide R into two regions of equal area, right? But do not solve an equation involving one or more integral whose solution gives the value of k. So in this case, we need to isolate x on both. So here x will be e to the power of y, and here x will be 5 minus y. Now, we can integrate from, to find the area, we can integrate from 0 all the way to k, right? Of what is the upper function? Well, the upper function, or no, not the upper, the outer function. The outer function is 5 minus y. This is the outer function, and this is what the inner function, 5 minus y minus the inner function, which is e to the power of y, equals what? Equals half of the area. We found the area in the first part, which is 2.986. This is the answer of part C. You don't need to solve, you just need to this is dy. You just need to set up the equation. Okay, I'll stop here and continue in some other videos. Thank you.